Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. I am your host, Dean Phillips, and I have with me as a very special guest and an unbelievable friend, Dean Phillips. Dean comes to us, of course, from Link Systems. He is a sales engineer and innovation strategist there. Welcome, Dean.
Thank you so much for having me today.
It's my pleasure. Tell us right away, what is the big takeaway as we look forward to the next 5 years?
It's a pretty difficult question to answer in a very concise way. There's so many different technologies that are moving forward at a very rapid pace. First off, I would say everything to do with smart. And that encompasses augmented reality, virtual reality. It also encompasses, of course, robotics, additive manufacturing, IoT. And consequently, all the technologies are advancing at such a fast pace that adopting these has been a challenge for most manufacturers.
What seems to be the biggest holdup on the advancement and the adoption rates?
Well, that's a challenge because most companies, when they get involved in IoT, they want to take a small bite, but they see the big picture of what they need to get to. And it's not easy for them to swallow how much investment it takes to get the return that they want to get. If you look at it from the standpoint of these small companies, everybody can gain information and data processing and augmented, but it takes a complete immersion in the technologies to really reap the rewards.
If you look at technology from the standpoint of where are we going and what can we get out of these, what areas are some of the more developed?
Well, that's one of those areas that everybody can gain from. The cost of processing things has come down so greatly. For example, 3D printers have come down in price, probably down to a quarter what they were. Of course, new technology comes out all the time, and that is still at a high price. But if you look at things like drones and you look at 3D printers and everything else, you can get into the market at a very cost-effective rate. Sensors for IoT are more available, and you can get some very high-tech laser sensors. All of the old technologies, and I don't want to say old technologies as if it's not important, but all of the older style sensors can certainly reap significant rewards for even small companies.
If you had to pick a technology that's going to make the biggest impact, what do you see that coming from?
Well, I think that if you look at the AR, VR world, right now we're having such a challenge for workforce development, and workforce development is at the forefront of every company. So consequently, they are trying to get people trained. Well, what does augmented and virtual bring for you? The virtual you can train off the floor. I can train my employees using a virtual reality program, get them versed in things like, just how do I set up a machine? How do I get it to the point where I at least have a significant ramp up speed? So when I walk in the door of the actual plant, I'm fairly familiar with how a machine runs, what I need it to do, and everything else. This also helps the weed out process because people are making a huge investment in people. If you tell them, look, you're going to be working from home for the next 2 weeks, and we're going to track your process on this virtual reality. And if they're not making that progress, it gets rid of some of these people that currently just don't show up Monday morning. I've heard that from many companies that they hire somebody on Friday, Monday they don't even show up. That's a problem. That's a problem for every company. And we don't want to be experiencing too much of that. If we can get them to a VR investment, that would help us greatly be able to determine if this person is viable as an employee. And I don't think that that's unreasonable to try and get them to some grade level of virtual experience.
So where do you take it from there? What's the next step?
Well, interestingly enough, the next step is then going from virtual reality to a level of augmented reality. Longevity Industries, of course, is doing a lot of this. But what it does is now I put on a set of a heads-up display, and I can see on the screen where I don't put my hands on the machine and where I have to pick up the part. So that in and of itself gives me an awful lot of feedback.
If you look at it from that standpoint, can that be used for other technologies?
Without question. If you look at how augmented reality is being used right now in service departments, you can have one master technician. Let's take a big company, and let's say you were a Google or something like that. I can have somebody in one central location that has probably the greatest expertise, but he can now work with other people, other technicians using HoloLens or even the now defunct Google Glass. What they can do then is I can look at what the problem is, have a meter or have some sensing device to test the equipment, and the other person on the other end of these now can use the system to draw circles or point to what they're trying to do, what they're trying to accomplish. Okay, you should be measuring at this point here. So put your one lead on the left here, you take your other lead and you put it over here. And that gives them a level of experience from actually having done this now that person is going to benefit greatly. And you don't have to have the high-level technician at every single location. That is unbelievably valuable. You don't have to have 50 of your most dedicated, think about something like an Apple. If Apple had this back in the day, you only need one Steve Wozniak because that's all you have is one. You're not going to get multiple ones. So consequently, that person can be the overarching administrator for this information. And then you have other ones working under that person who may not have the experience of a Steve Wozniak, but can experience that level of mentorship. And you can have a journeyman electrician working with an apprentice, but not having to do it right at that location. And if you have a limited number of high-level resource people, this can be really helpful to you to help you make sure that you can reach your goals now. So that's a big difference.
So let's take a look at other technologies that we see, robotics, let's say, for example.
Well, I like to group robotics and drone technology together because they're similar in many ways. The aspect of working and operating something remotely can be very valuable. Nowadays, we have, for instance, fork trucks can be driven remotely. That is an element of robotics and even a somewhat level of autonomy, if you want to look at it as an autonomous vehicle. You can do that. So a fork truck that's configured with the right equipment can be driven remotely from another person. So let's say you're a small company and you just have a shipment during the day and I need a fork truck to move it onto the truck for 2 hours. That's all I need my fork truck driver to do. Now, mostly they would have a person that they would either be paying him for not working the 8 hours, but they would have him do something else. Or the other aspect is now I can pick up the phone and say, hey, I need somebody at 3 o'clock today from 3 to 5. Okay. And you pay them a certain rate. They do this, and that's all you're paying for now. Also, you don't have to pay to train that person. You don't have to have their certification and all the other things that they have to do in order to be a certified fork truck driver. This is very helpful for us now as we're getting into more of these remote worker experiences. Think about how many people now are working from home and want to continue to work from home in these environments. Well, we have to develop some new opportunities for those people because they're not wanting to work in a plant again. They're just not interested in it. Hence the reason we have this workforce shortage. But if we can find a way for them to work remotely and do their job, then that might be what we have to do. That's going to be where most successful companies are going to come from, operating a machining center remotely. Maybe the day will come in the future where you walk around a plant and there's nobody in the plant. Everybody's working remotely, but there are robots doing things. There are autonomous fork trucks. You have drones doing tasks. There will always be a level of humans that are doing something within that plant, but it's possible that the majority of the workforce will be working remotely. And that's an opportunity to reduce hazardous experiences, let's say. If you're trying to reduce risk and hazards, think about drones. I can take a drone now and I can fly a drone over a certain machine, and I can measure the temperature of the bearings. I can measure what the production of the gas fumes is. I can measure size, and I can actually do measurements. All of those things are possible. I can even fly one or even use a robot to drive into a confined space. Think about what it takes today for you to operate within a confined space. What do you have to do? I have to have permits. I have to have somebody trained. There has to be another person there when that person goes in. There's a lot of things that are at risk when you send somebody into a confined space. Well, why would we even put a human being at risk to do that for the first view? So now, let's say I'm trying to see if this pipe has a break in it. Well, I can drive a robot into there, or I can fly a drone into that area. Those kinds of things are available right now, and reduce your risk, reduce your insurance, reduce some of the hazards that you're exposed to, just that simply.
It almost seems too futuristic in many ways, but it is here now, right?
Oh, absolutely. This technology exists currently. That's not something that we have to wait for years. And referring back to what I mentioned when we started, there's no question that the cost of these things have come down greatly. You can buy an entry-level drone for a few $100s. And what it gives you, you don't have to have a high-tech, unbelievable drone. Now, to do temperature testing, you have to have a better camera, a better drone, et cetera, et cetera. But just to fly in and view something, let's say even in construction on a site, I want to get a good view overhead. Well, I can fly a drone up and view the progress, and I can send those pictures to actually show true real-time experience of what progress we're making. And that would be very difficult to do in other formats. On the other side of manufacturing, the more things we can do that reduce risk to the employees, the better off we're going to be.
If you had to think of what areas augmented, or not augmented, but AI, artificial intelligence, is going to improve, what areas do you think that will be?
Everything and anything. When you look at how artificial intelligence is working today, how we're using it, you see it being applied in all sorts of diagnostics and databases. There are systems out there that look for anomalies. So if we're doing this job today on this machine, I could constantly track it, and then I can watch the trends that it progresses at. And there are certain thresholds where things take off, like bearing failures, for example. If I'm going to have a bearing fail, I could trend it today and watch what happens. And what's going to be indicative of this is that I can also trigger a response because of it. So what is happening? I see the bearing is failing. As our systems and our databases get better, which they should already be doing, we should be getting better knowing what bearing that is. We should know where we buy that bearing. We should actually be able to even implement where we're purchasing that. So now if we watch and trend vibration of the machine, so as the bearing starts to fail, we can measure that. Another thing is bearing temperature. So as we visually monitor the bearing temperatures, I should be able to automatically say, order this bearing from Timkins. And it should be automatically done because you know that this bearing is starting to fail. What you don't want to do is wait until that bearing fails before you go and order a bearing. That's where the cost goes up dramatically for maintenance. And we've been kind of at that level historically for the last few years because we wanted to reduce how much inventory we had. So we don't keep on hand every single component that we need, but we can start trending and analyzing the data of when we order things. And instead of not ordering until it fails, or the other side of the spectrum, which is you order and have everything on hand, and there's a huge cost associated with having every single component you could ever need on hand. So those are your two extremes. You have everything you need, or you have nothing, and you wait till it fails. And both of those two have a huge cost associated with it. One is inventory that you have associated with it, that if you have everything you need, there's a huge inventory cost. The other side is an expediting cost that comes from waiting to the last minute to order something, and you're having things flown in, having to have them rushed, and even then you're still down for a period of time. Predictive analysis, that is where we're trending in the AI side of things, is really important because by following those trends, we can be predictive in what we're trying to do. Not doing preventive maintenance, which is removing it before it's failed, or removing it before it starts to trend down just because every 6 months we replace these bearings. Well, there's probably a lot of good bearings we're throwing away because there's no indication that they have started to wear to a point that they need replacing. You see this even in tool and die manufacturing. A lot of times you have one extreme or the other. You're either always replacing and always sharpening this die, or you're on the other side of it, which is you're waiting till it fails, and then you have somewhere else, which is the using intelligence, things like tonnage monitor. If I'm doing a tonnage monitor, I can see when the tonnage is starting to trend up and the tool needs to be sharpened. And it's certainly responsive to people to use things like those tools. Problem is, we still today don't use tonnage monitors at every company. I've gone into lots of manufacturers across the country, and only a very small percentage utilize their tonnage monitors. Most of them don't actually use them. They have tonnage monitors, but are not using them the way they should. Once I come up with the optimum tonnage, I should then be able to tweak that number based on materials or lubrication. But if the tonnage is starting to trend up, you should know that. And you should have somebody there then that this can then get accelerated up the ladder to say, okay, is this a problem or is it just material that's creating this problem? And somebody should be able to give a thumbs up, thumbs down on that material. You should be able to check the hardness of that material and say, this is harder than the other material, or this is thicker than that other material, therefore it is going to generate more tonnage. But you should have a system in place for that. But if you completely ignore the tonnage values, then you're back to what I said before. The only time you're seeing that tonnage go up is when you hit two parts or there's something else that happens. That's not very helpful. Same is true for, let's say, on a machining center. Your spindle speed and your material hardness there. Okay, am I running at the right speed? Do I have the right lubricant? Do I have enough lubricant? And or is this a problem with the material? So that those kinds of things need to be utilized. Utilization is one of the biggest problems I see. We have more IoT than we used to have. We're gathering more data, but we need to utilize this. And I think AI is going to go a long way to help us on that, because what's happening now is we're gathering all this data, but we don't know what it means. That's the problem we have for so many people, is we're gathering data. Even people that have tonnage monitors are gathering data. Well, if it hits over tonnage, they just bypass it or they raise the tonnage limit. They don't actually analyze what's going on with that. So we have to do a better job of our analysis of this data in order to utilize it for the maximum return.
On the side of additive, what are you seeing in that area?
Additive is really exploding in some new materials. There are more ways that we have now to do things with printing. I'm sure most people have seen the videos of where they're additively printing a house. So basically they're controlling the flow rate of concrete, and they're moving what would be the head, but basically how much concrete is coming out around the house. So they're building these houses out of concrete. And yeah, those kinds of things are really where the interest, I believe, is coming from, is utilizing these materials in some way, shape, or form. People don't always think of welding as an additive process, but that's what it is. You are adding material, and I can layer it upon layer upon layer upon layer and build this structure. Of course, there's metal 3D printing, which is similar, like powdered metal, where you layer up these materials and then you compress them, and that heat transfers, and then that causes it to the material to basically liquefy and turn into to where it can actually flow, and that material can actually flow in a way that makes it a solid when it cools from that heat. Now, with more and more of these additive processes that we have in every kind of material, whether it's a very rigid plastic to a very soft and pliable material. There are more and more materials being developed every day. Of course, we can always print food. Hershey's has where they're printing chocolate in all different shapes on a 3D printer. You can print pancakes. I've seen people print pancakes with instead of the head that is moving back and forth, printing a plastic. It's moving around, printing the dough for a pancake, and in different shapes and different forms. Think about clothing. People have done for quite a few years now that are actually printing clothing, material that is, some of it is more rigid, some of it is more pliable, and more like a rubberized product. And we've had at some of the FabTech shows in the past and at the Additive shows where we've had a fashion show with clothing from these people that are doing additive and are printing this stuff. It is pretty amazing where that technology is.
It's an amazing time, I guess, for us when we look at technologies. So as a closing statement, where do you think 5 years from now we're going to be in all of these technologies?
Whew. My expectation is we will go into the future kicking and screaming slowly. I think the adoption rate will be coming, not as fast as we would like it to, but I think people are going to have no other options. Just like you can say even electric cars. Whether you like it or not, the electric cars are the future of a lot of aspects. Now we're getting better at battery life. We're getting better at distancing that can travel. All of these technologies are improving, and the biggest thing is cost. As the technology improves, the cost comes down. Computers have come down in prices. Now they're also adding more features in order to keep that price up there because nobody wants to be in the $100 computer business. It's not where they want to be. Most of these manufacturers don't want to be selling $100 computers. But if they sell $500 computers, they're interested in that. But how do I get there? I have to keep adding more features, more benefits, and constantly work to develop. And that's kind of what drives technology, to be the faster, the biggest, the best. And that, unfortunately, hasn't come back to bite people in many technology areas. Some technologies move slower than others, and the adoption rates are in accordance with that. The people that it's going to hurt you if you don't have a laser that is a certain wattage or has a certain speed, that's going to make you less competitive compared to other companies when it comes to quoting fabrications. So the adoption rates are higher in those technologies than in areas where there's no differentiation between using a hammer or using a stamping press. If that's the case, then there's no benefit to me exploring this level of technology. Consequently, we just have to keep looking forward and do adopt as things are coming along. And as they do, the opportunities will be there for those that are quick and swift.
Thank you so much. We really do appreciate it, Dean, for being here today. Dean Phillips, of course, from Link Systems, and also, of course, from Longevity Industries.